Hello everyone, Energy Crafts here again. If you've been following my last few videos, you saw that I had a simple solar batch hot water system and that you're looking at right now. I hinted at the last of my videos that I was going to be making some design changes due to the various different inefficiencies that I had pointed out in those previous videos. And today I'm going to show you my proposed new upgraded plan, and I'll take you to a diagram to show you the changes that I've made for building a new design. Okay, here we go. Okay, so here's a diagram of my latest proposed design. I think this one will be much better than my previous, and the only real difference in this design in the earlier one is the introduction of the helicoil HC50, which is right here, and the fact that it this is made for a pool heater panel, and I'm taking a fitting on the bottom side of the panel and a fitting on the opposite side of the top and running that into where the normal heater elements would have been in my batch tank. That's open for debate as far as on this bottom one whether I use the actual heater element port or if I actually go to the drain like I did on my earlier design. This design alleviates, I believe, most of the problems that we had in the previous batch design. And first thing is I had pointed out that there was a thermal boundary layer mixing problem, and to fix that, previously I mentioned the fact that you could spend extra money and use a circulation pump, which would entail more complexity, and an extra power source, and so on. In this design, because I'm using this panel and because I've got it tilted at an angle, and if you'll notice at the upper fitting, that pipe goes to the upper element, which is almost horizontally across. A little bit of adjustment there, we can play with that to get it right, but the bottom line is the lower element port is the cooler water in the batch tank, and the upper port would be the hotter water. So the effect is that we're going to have thermosiphon principle, where the cold water keeps sinking to the bottom, the hot water keeps rising through the pool heater panel, and it should have its own circulation there, and that'll alleviate our problem of heating as much water as possible in the shortest amount of time and doing it for free without using a circulation pump. Okay, another problem I had mentioned earlier on the earlier design was the heat exchange problem between the metal tank casing and the water was a very poor contact because only half of the tank was actually contacting the water, and the other part was having to suffer through an air pocket. In this design, the batch tank is vertical to the ground, so there is no air pocket there. There's no place for just to be an air void, so there is total metal contact all the way around, and it actually doesn't matter in this design because obviously the sun's not heating this tank specifically, but in using this heater tilted at an angle, the black section here is a pipe that's got parallel connected tubes going all the way to the bottom, and this is a pipe as well. So all these tubes are connected in parallel, so there's no air pocket there. So the issues about an air pocket here on the previous design is irrelevant on this case because there is no air pocket, and there is contact with water per surface area much greater than there ever was in the earlier design. Another thing is in the previous design, we depended on the sun to be able to affect only the surface area of this tank in order to get hot. And that area only amounts to about 5.9 square feet of surface area. So that's all the energy input we could possibly have from the sun. On this design, the helicoil HC50, that's roughly about 40 square feet of surface area in terms of what the sun can hit and convert to heat. So the results is that this design here will be, I calculate, about 6.78 times more energy conversion than there was in the previous design, simply because it's a larger area that the sun can affect to produce heat. The general rule is it's about 1,000 watts per square meter. This heater panel is about 4 foot by 10 foot roughly. So the results is that's about 4,000 watt hours of heat that can be converted, whereas in our earlier design we were depending just on the batch tank to produce heat, and that was only 5.9 square feet. So the results is I've got 6.78 times more collectible energy in this system than before. So I have lots more chance to bring this batch tank up to temperature before the sun goes down. And the HC50, by the way, is, according to specs, is rated at 47,400 BTUs per day. So that should be pretty good to heat this batch tank up long before the sun goes down on an average day. The other problem we had with the previous design, I just touched on it a little bit, is that because the sun can only touch a small area of surface on a batch tank, it didn't have much of a collecting capability, whereas in the helicoil design, you're running water through parallel tubes that are relatively thin, and therefore there's a great surface area of sun conversion to heat capture. Okay, well that's pretty much the general design, and now I'll show you some of my parts that I'm getting ready to prepare to assemble. Okay, I'm over at some of the parts I've laid out in the yard so that we can see them better. This is the HC50 helicoil, what's normally used for heating up swimming pools. I did consult the engineer, and the only thing is he said he wasn't sure if it would work with thermosiphon. So we're taking a chance on that, but I got this free from Craigslist, so not a big deal. If it doesn't work, we'll just use a circulation pump if we have to. I'm going to give you a little zoom closer up so you can see these tubes. You can see that they're parallel tubes, and on one end it's just a larger pipe, open on both ends, but they come with certain fittings where you can plug up or make a threaded fitting to go to whatever you want based on coupling, based on these coupling sections right there. There's an O-ring that goes in there with a little coupler, which then adapts to Schedule 40 PVC or CPVC, whatever you want. Like I said, this panel is about 4 foot wide and 12 foot long. So it's a little bit better performance than even I had mentioned earlier. In order to set this up, I'm planning on adapting this large piece of thin paneling and a basic frame, and that'll just be used to support the helicoil panel at the right angle later on. And the paint I'm going to be using to paint this frame black is, let me see if I can get you on it. This is just what I have. It's satin black, Rust-Oleum, and it's made for barbecue grills. So I know I should be using flat black, but this is what I have, and that's what I'm going to be using. Alright, in order to support this stand frame, what I mean is in order to support this frame, I have to build also a stand. So I've started on that. Here's a basic frame. And so that'll raise up the upper end so that we can face south later when we orient this properly toward the sun. Okay, that's about it for now. Please like, comment, or subscribe, and I'll keep you updated on how this assembly goes, and hope to see you again. Thanks.